Okay, I'm going to do another dihybrid cross, and we're going to follow the same rules again. This time, I'm going to do a dihybrid cross that isn't as, I guess it isn't as complicated, but you have to do a little bit more problem solving on this one, but it is a little bit easier. So let's say we have an individual that is this cross. Okay, actually, let's do this. Okay, so what we want to know from this cross, so this individual, the phenotype, and we'll go back to the same, let's see, we'll bring this back. The same phenotype, so big A, so A is going to symbolize the color of the seed. And then, Richie, I will feed you in a minute, okay? I told you I needed quiet, all right? There's also toast on the table. Well, you should have told me. I'll feed you in a minute. Okay, so I can't pause these. I apologize. Okay, so then the shape of the seed, so round versus wrinkled, is going to be B. And so this one, phenotypically, little a, big B, little b, is going to be green seed and round. And then big A, big B is going to be yellow and round. Okay. Okay, so let's see what the phenotypic ratio of this particular cross is going to be. Okay. All right, so again, we're going to foil. And don't skip any steps, okay? So do not skip any steps when doing this cross. I don't know. Richie, please, let me finish. Okay, so what you're going to do is foil. So it's going to be this outside one can pair with this. And so what I would do is draw the arrows, okay? And in this case, A is going to go first and then B. So it's going to be little a, big B, and then little a, little b. And then here, little a, big B, and then little a, little b. Okay, and then we'll do this one. So we're going to foil it. So we have big A, big B, also big A, big B, little a, big B, and little a, little b. Okay, so now we have some repeats here, right? Because this is little a, there is only going to be one allele type for this particular one, which is going to be little a. So what you want to do here is you want to look to see if there's any repeats. Okay, so here we have a repeat. So we have little a, big B, and then little a, little b. So these are repeats. Cross them out. These, there's also repeats here. So it's big A, big B. Big A, big B. These are repeats too, right? So there's only going to be two unique allele types here, okay? So there's only two here and there's two here. So you're going to draw two lines and then another two lines. And then what you want to do is you want to X out this corner one because you don't need it, okay? Then you're going to line up this, so little a, big B, and then here, little a, little b. And then here we have big A, big B, and then little a, little b. And then you're going to combine them. So this is big A, big B, big B, big A, big B, little b, little a, big B, and little a, big B, little b. Okay? All right. So this is all we have. This is the only offspring that this particular cross can produce. So let's look at this. So here, let's see, this is, let's go back to this. So let's look at this real quick. Let me assess this real quick. So you are only going to have yellow round, and then also green, looks like green round. Is that right? Green? Yeah, green round. so let's look at the phenotypes here. I apologize, my son is now playing with the synthesizer. Okay, so we have yellow round. This is yellow round, and this is also yellow round. So we have 1, 2. Let's look at green. I wanted the orange highlighter. I had a kid in here a minute ago and they're just playing around and now everything's gone. Okay, fine. Okay, so green round, and there's gonna be 2 of those. So it's gonna be a 1-to-1 ratio. Okay, so just remember that if there are more than one unique genotype, to cross it out, and you don't need to use them. Okay, so this is this particular cross. So the next thing I want to go over is, let's go over what was in the active learning when it comes to dihybrid crosses. Okay, so here's this one. All right. So dihybrid cross is a cross between 2 different lines, variety strains that differ in 2 observed traits. Attached earlobes is dominant to unattached earlobes. Rolling the tongue is dominant to not being able to roll the tongue. 2 people decide to have a child. Both are homozygous, one for tongue rolling and unattached earlobes, and the other for not being able to roll the tongue and attached earlobes. So here are the genotypes. What is the genotype for each parent? So let's go back. So 2 people just decide to have a child. Both are homozygous, for one for tongue rolling and unattached earlobes. Okay, both are homozygous. One for tongue rolling and an unattached earlobe. So tongue rolling and unattached. Wait, both are homozygous. One for tongue rolling and unattached earlobes. So tongue rolling, so that would be an unattached earlobe, so that would be big E, big E. So that's, so unattached ear, oh, sorry, that's little e, and tongue rolling, which is big R, times, and the other for not being able to roll the tongue and attached earlobes. Okay, so attached earlobes, so big E, and then little r. Okay. Okay, so what are the genotypes of each parent? So this individual and this one, that's, oops. Okay, what are the genotypic and the phenotypic ratio of the offspring of this cross? So this individual, even if we foiled it, okay, so if we did the whole foiling thing, since they are homozygotes, then the only thing that they're going to produce is little e, big R for this one. And then this parent is only going to make big E, little r. And so all the offspring are going to be big E, big R, little r. That's it. All right. And then they're all going to have attached earlobes. And they are all going to be able to roll their tongue. Okay. Okay. So using the same traits as above, 2 parents who are both big E, big R, little r decide to have children. What are the phenotypic ratios of the offspring of this cross of traits mentioned above? Okay, now we're in a situation where both parents are basically heterozygotes. So we have big E, big R, little r, times big E, big R, little r. Okay, so the first thing you want to do is to determine the gametes that they can produce by foiling. So this parent can produce big E, big R, big E, little e, big R, and little e, little r. And this one is the same. So it's going to be big E, big R, big E, little r, little e, big R, and little e, little r. The reason why I know they're the same is because the parents are they have the same genotypes. There are 4 unique ones here and 4 unique ones here. So you're going to do 1, 2, 3, 4, and 1, 2, 3, 4, block out the top left corner. Okay, so this will be big E, big R, big E, little e, big R, and little e, little r. And the same here. Okay, and then let's do this cross. I'm just going to write it in. Sorry, it's so small. Okay, so the next thing you want to do is you want to determine the phenotypic ratio. And so so there's the parental one. So here, I'll do it over here. We don't have that much space, I'm sorry. So this will be attached tongue roll, and then unattached roll. Okay, so anything that's going to be attached and be able to roll is going to have a big E and a big R. Anything that's unattached and can roll is going to be a little e, big R. And this one is going to be big R, big E, little r, and this one's going to be little e, little r. Okay, so... All right. So this one, which is going to be this, and this. So it's going to be 9 of those. Need 3 of those. Sorry, I'm running out of pens. I don't know what happened to them. And then do 3 of those. And then finally, there's only going to be 1 of these. So you'll see that 9 to 3 to 3 to 1 ratio. Okay, and that's what you'd expect to see in normal Mendelian genetics dihybrid crosses. Okay, so this next one is epistasis. Epistasis is basically, it's the same thing as it's the same dihybrid cross. And like I said, all these Punnett squares are basically the same. It's just the analysis is different. So with this one, so epistasis describes a phenomenon when one gene affects the phenotype of another gene. In corn recessive epistasis, also known as a modifying action, 9 to 3 to 4 ratio, the dominant A gene produces a purple kernel in the presence of a dominant allele for gene B, but does not express an effect if other gene is recessive, little a, or little b. So the F2 progeny with this genotype. So that little underscore means that an allele can be there, either big A, little a, or big B, little b, and it'll give rise to the same color. So instead of the 9:3 to 3:1 ratio you'd expect to see, so with a dihybrid you'd see a 9:3 to 4. Okay, so basically what happens is that one gene influences the outcome of another gene. They're still independently assorting, they just kind of affect each other in a phenotypic way. Okay. All right. Okay, so they're purple. So do you see how there's only 3 phenotypes, whereas with Mendel's P's are 4? Anything with a big A and a big B are purple. Anything with little a, big B are red. And then anything with little b are colorless. Okay, so 2 corn plants have this genotype due across these 2 plants. So do the dihybrid cross like normal. It's just the analysis is different. And so make sure that you're going to see that 9:3 to 4 ratio when you're done. Okay. So that little a, little b, which in the other cross had its own distinct phenotype, is the same as one of these phenotypes. Okay. This one, we'll do this one. So using the same genotypes and phenotypes as above, do a cross between 2 plants with the following phenotypes. What are the phenotypes of the parents? Do the cross below. Okay, so we have little a, big B, little b, times big A, big little b, okay? All right, so you foil. You foil this. Okay, so there are some repeats. So these are repeats, and then these are, these are repeats. Okay, so these are the only unique phenotypes you're going to get. So you're just going to do 2 and 2. So little a, big B, little a, little b, and big A, little b, and little a, little b. Okay, so all right, so anything with a big A and a big B is going to be purple. So that looks like there's going to be 1 purple. Okay, so that's that one. And then anything with 2 little A's are going to be red. And so there are 2 little A's here. Except this one actually is going to be white, because anything with 2 little B's is going to be white. So there's going to be 1 red, right? Yeah. And then there's actually going to be 2 white. So anything with 2 little B's is going to be white. So these 2 are going to be white. Okay. So the ratio is going to be 1 to 1 to 2, or 1 to 1 ratio of the phenotype. So it's going to be a 1 to 1 ratio, purple, white, and red. Okay. Okay. All right.